Today we're learning to find out the equation of a straight line when we're given the gradient and the y-intercept. So that's something that's reasonably basic for us to do using y equals mx plus c. Beyond that, what we're going to be looking at is finding the equation when you're given the gradient and a point. And then what we'll be looking at is finding the equation when we're only given 2 points on the line, and we'll work it out from there. And we'll finish with 2 exam questions for this topic. So for this video, I'm just going to be using y equals mx plus c. In a future video, what I'll be doing is using y minus b equals mx minus a. So I'd like to try it this way first of all and let you see how to work these through. So this is a bit of revision for you at the moment. So we're going to work with y equals mx plus c. We've been given the gradient, we've been given the y-intercept, which is the c value that's there, and if I substitute the 2 in where m is, the 5 in where c is, it basically gives me the equation of the straight line. So for a, I've got y is equal to, so 2 instead of m, I've got an x, and that's going to be plus 5. So that's all we're doing there. That's the equation of the straight line. So that tells me that we cut through the y-intercept at 0, 5. Okay, 5 up on the y-axis, and we've got a gradient of 2, so along 1 and up 2, along 1 and up 2, along 1 and up 2 as we go along. Okay, so that's revision. Okay, this one here, I've got a gradient of -3, and I've got a c value of 4. So if I substitute that into y equals mx plus c, all I'm doing is putting the m in where the m is going to be exchanged for -3, so y equals -3x, and the 4 for the c value. Plus 4. Okay, cuts through the y-axis at 4, or the coordinates 0, 4, and we've got an m value gradient of -3. So along 1, down 3, along 1, down 3. So that's what that is. Right, so even when we've got fractions, these are reasonably easy as well. So all we're using is y equals mx plus c. All I'm doing is substituting a half in where m is, and -1 into where c is. So the equation is going to be y equals a half x minus 1. Okay, no more work than that. Finally, just for this little part of revision, I've got a gradient of 0, I've got a c value of -8. Okay, so we know it's going to cut through the y-axis at -8, and we're going to have a 0 gradient, so it's going to be a horizontal line. So just to go through the mechanics of working this one out, all we would do is substitute a 0 in here, so y is equal to 0x, and we've got a take away 8. But nothing times x, or 0x, is going to be 0 anyway, so that's going to be y is equal to -8. So just a wee bit of revision to see how the gradient slots in and how the c value kind of slots into these equations here. Right, moving on. For this one here, what we've got is we've got a gradient given to us. Okay, this is when the gradient's given, but we've got a point where it passes through, but that's not a point that's on the y-axis, so we're going to have to do a bit of working out for this one here. So what we're going to do is we're going to substitute the gradient into here, just like we did in the last slide that we had there. And what I'm going to do is I'm going to use this as my x-coordinate, so x is in where x is, and 8 is my y-coordinate, so that's going to go in there. So let's start by writing down the equation, y equals mx plus c. I'm going to substitute all these values in. So I've got m is 3, okay, so 3 for m. I've got my x value is 2, so it's 3 times 2. I'm going to just put it in a bracket if that's okay with you. So that's 3 times 2 that's sitting there. I've got a plus c there. That was my x value. My y value is 8, so 8 will appear on this side here. So 8 equals 3 times 2 plus c. So if we're solving that equation, all we would do is we would solve it. So I'm going to multiply these bits together here first. And then what I'll do is I'll take 6 away from each side. That'll leave me with 2 on this side, and that's c equals 2. Or if I just reverse it round, c equals 2. So then what I'm going to do is I'm going to substitute the values that I've got for my gradient. So my gradient's 3, and my c value is 2, and all we're doing is back to what we started with on the previous slide. We're going to substitute these 2 values in there, and that will give me the equation of my line. Okay, that's all I'm doing. So sometimes it'll get a wee bit more complicated, okay, as we go forward. It gets a wee bit complicated when it falls off the end of the camera, but this is all we're doing here, putting in the 3 where m is, the 2 in where the c is, putting it together, and that gives us the equation of the straight line. Okay, so that was a straight line with a gradient of 3, and it's passing through the point 2, 8, and that's its equation. So let's go for the next question here, okay? So what we have is m equals -4, okay? And we've got a point 1, -7. So let's work this one out the same way. So we're going to use y equals mx plus c. That's all we're going to be using at the moment. So we know our gradient for m is -4, and the coordinates for x and y, there we go, x coordinate, y coordinate there. They're going to be substituted into this equation, okay? So I've got -7 is equal to -4 from there. I'm going to be multiplying that by the x value, which is just a 1, plus c. So this allows me to work out the y-intercept, the c value. So when I multiply that together, I've got -4 plus c. I'll add 4 to both sides, okay? So that's going to give me -3 is equal to c, okay? And c equals -3. So I'm just going to substitute that value there and the gradient value in. So we're substituting the gradient of -3, and we'll substitute that point there that we worked out. Oh, sorry, gradient of -4. Okay, I've just seen it from the top, okay? And the c value of -3 into the general equation, okay, that we use, okay? So from there, I'll just substitute in. So -4 going in where the gradient is, and the -3 going in where c is. So that'll be a plus a -3, or just a -3, as that would come out to be there. Okay, on to the next one. Right, what we have over here, we've got a gradient of 2, and we've got a c point is going to be -6, -8, okay? So that's my x coordinate, my y coordinate. Remember, I'm using y equals mx plus c as the equation I'm going to use to work out the y-intercept. So that's what I'm trying to get first of all, okay? So let's put our points in. So -8 is y, m is 2, x is -6, and the c is just a plus c, because that's the one I'm trying to work out. Okay, so that's the y-intercept there that we're working. So if I multiply these together, I get -12 plus c, and then all I'm going to do is add 12 onto both sides, just like we do with solving equations to work out what c is, and that's going to give me 4 there. So c is equal to 4. Remember, substitute my gradient, so looking up to the top to get my gradient of 2, and the c value, which is the intercept, okay, for the y-axis. And remember that intercept says 0, 4 if you're asked for the coordinates of it. Okay, and we're substituting these two things into y equals mx plus c, and all we do is we put them in, and that will give us our equation of the line. So that's going to be a 2 in where m is, 2x, and the c value is a 4. So for the line that's got a gradient of 2, it passes through -6, -8. Well, the equation of that line is y equals 2x plus 4. Okay, so what we're trying to work out here now is when we don't know what the c value is, we don't know where it cuts through the axis, but what we can do is we can still work out the equation based on the information that we've got. Right, I'm going to do another 2 with fractions in them, okay? So you can see what we do when we've got fractions, and it's just the same thing. So the type of question would be, find the equation of the straight line with gradient of a half, and it passes through the point 6, 10. Okay, so let's go and do that. So we're going to use y equals mx plus c, and the reason why we're doing this is to find the value that's the y-intercept that's there. Okay, so we know that that's x and that's y. We've got an m there as a half, so let's just substitute in. So that'll be 10 is equal to a half times 6 plus c. I'll work out half of 6, that's just going to give me 3 there. And what I'll do is I'll subtract 3 from both sides. That should give me 7 is equal to c, or c is equal to 7. Okay, so that's me got that worked out already. So what I'll do is I'll substitute. So I'm just writing substitute my gradient up here, which was a half, and the c value, which is 7, and we're going to substitute that into y equals mx plus c again. Okay, So from there, I can just get my equation. So y is equal to a half x, and that's going to be plus 7. That's there. Okay, so what we've worked out there is the equation of a line that's got a gradient of a half, passes through the point 6, 10, and that would be the equation of the line. So and from that, remember, we can say that it passes through the point 0, 7. Okay, that's where it would cut through the y-axis, up 7 on the vertical, and the gradient is going to be a half, which means it goes along 2 and up 1, along 2 and up 1. So we've got that one. We've got a gradient here of 3/4. We're passing through a point 8, negative 3. And what we're going to do is we're going to work out the equation of that line. So, same again. Okay, we've got an x value there, y value there. So remember, I'm going to be using y equals mx plus c. This is the only equation I'm going to be using for this at this moment in time. For this one here, we're going to substitute our values in, so negative 3 at that side. I've got 3/4 as my gradient for m. For the x value, I've got 8, okay, and that's plus c, because that's the one I'm trying to work out. I'm trying to get this one here. So 3/4 of 8, okay, so remember 3/4 of something. What we can do is we can divide by 4 first of all and get 2, and times 2 by 3 and get 6, okay? Or, there's different ways that we can work this one out, okay? Or we could multiply across the way. Remember, 8's like 8 over 1, isn't it? So that would give us 24 over 4, and 24 divided by 4 gives me 6 as well. So there's different ways you can work your fractions out, okay? So that's going to be here. So that there is going to work out to be, so I'm just going to go take 3/4 of 8. 8 divided by 4 gives me 2. 2 times 3 gives me 6. Okay, there we go. I'm going to take 6 away from both sides to eliminate this part here. What that leaves me with is a negative 9 or minus 9 at that side there. So c equals minus 9. All I'm going to do now is substitute it into the formula. So substitute the gradient that we were given. Gradient was 3/4 up at the top. And the c value that we worked out was minus 9. Substitute it into y equals mx plus c again. So the equation of this line here, with a gradient of 3/4 and passing through the point 8, negative 3, is y equals 3/4x, or 3/4 x, minus 9. Okay, so what that was there is, so we've worked out the equation of the line when we're given the gradient, and also the c value. In this one here, we've not been given the c value, but a point, and we've worked that out from there. Okay, right, we're moving on to something a wee bit more complicated, but we're just going to be working out the same type of thing that we've been doing. So this is the type of question that's more generally into the exam kind of style of this type of work for the equation of a straight line. It's when we're given 2 points, and what we've got to do is to work out what the equation of the straight line is. So for part A, what we're going to do is we're going to work that out. Okay, so if you remember the gradient formula, so remember we don't have a gradient given, so I need to work out what gradient is. We've not been given a y-intercept, so I need to work that out as well. So let's go ahead and do that. So we're just going to use what we know already. So we know how to work out the gradient. So my gradient, okay, so remember we use m for the gradient. So m is equal to y2 minus y1 all over x2 minus x1. I'm going to try not to use that formula all the time. I'm just going to substitute my numbers in as we go forward, just to make things a wee bit quicker for the video that we're doing here. So y2, I'm going to take 7, okay? So I'll just write this one up first, okay? x1 and y1, x2 and y2. So this is the way that we're going to go forward, okay, with this. So 7 take away 3 on the top, 3 take away 1 on the bottom. So 7 take away 3 is going to give me 4. 3 take away 1 is going to give me 2. And 4 divided by 2 gives me 2. So I've got a gradient of 2. So I know I can substitute a 2 into there. Right. So what I'm going to do now is I'm going to do what we did in the previous slide. What we're going to do is we're going to use the gradient and one of these points. Now it doesn't matter which point you choose, it'll still work out to be the exact same equation. I'm going to use the one that's the easiest to work with. I think 1 and 3 is going to be the easiest to work with. So what I'm going to do is I'm going to use y equals mx plus c. And what I'm going to do is I'm going to substitute 1 and 3 in. So 1 for x and 3 for y. So let's go for that. 3 is equal to m. The gradient we worked out was 2. The x value is 1. And the c is the thing that we're trying to work out now, because I don't know what that is yet. So 3 is equal to 2 plus c, and what we'll do is we'll subtract 2 from both sides, and that should give me c equaling 1, because that eliminates. So c equals 1. That's me got everything I need. I've got the c value, the y-intercept, I've got the gradient, and I'll just put them together in y equals mx plus c, the equation of a straight line. So y equals mx plus c, and what we're doing is we're substitute the gradient is equal to 2 that we worked out, and the c value is equal to 1. So let's go and do that just now. So y is equal to 2x plus 1. And that's all we do for that type of work there. I'm going to rush through a couple of more questions that I'm going to do with you. You can stop the video, rewind it if you need to review it again and see where I'm getting my answers from. Here we go. So I've got this one here. So I'm going to have to work out the gradient. Okay. So my gradient is equal to minus 6, take away 0, that take away that, 1 take away minus 2. So I've got two negatives that are there. Gives me minus 6 on the top, that'll give me 3 on the bottom, that gives me a gradient of minus 2. Remember, I'm going to use y equals mx plus c, and I'm going to use one of these points. I'm going to use this point for my x and that my y. So I've got 0 at this side. M value I worked out was minus 2. I've got an x value of minus 2 as well. Okay, and I just need to be careful on my negative number. So negative 2 times negative 2 gives me a positive number, so that will give me a 4 that's there. And then all I'll do is I'll take 4 away from each side, eliminates that one, so that gives me minus 4 equals c, or c equals minus 4. I'll then substitute what I've worked out, the gradient of minus 2 and the c value of the minus 4, substitute them into y equals mx plus c again. Right, so here we go. Y is equal to, and the gradient was minus 2x, and the c value is minus 4. There we go. That's the way we would do that. You can freeze the video and try the next one if you like. I'm just going to work through these as we go. Okay. So for this one, we don't know the gradient, we don't know the c value, so I'm going to work both out. So first thing is the gradient. So it's minus 3, so this one here, take away minus 1. Minus 3 here, take away minus 7. So that's going to be a plus 1 that's there, so that'll be minus 2 on the top. That'll be a plus 7 there, so that'll give me a positive 4 on the bottom. So it gives me a minus a half if I simplify that fraction down. I'm then going to substitute into the equation, y equals mx plus c. I'm just going to use, which one will I go for? I'll go for this one here. I'll just go for the first point each time, so x and y. So I've got negative 1 is equal to my gradient, which was minus a half. The x value here is minus 7, and I've got plus c, and this is what I'm trying to work out this here. So what I've got here is minus 1, and if I multiply a half times 7, I get 7 upon 2. These two negative signs are going to cancel out when I'm multiplying, so two negatives. Okay, and that will leave me with 7 over 2, and that's plus c. Okay, or 3.5, you know, if you think about it that way. Right, so I'm going to try and gather these up. So I'm going to take 7 over 2 away from that side. I'll take 7 over 2 away from that side, or 7 halves. So these get eliminated, and what that will leave me with, it will leave me with a minus 1 take away 7 upon 2 is equal to c. So when we're dealing with fractions, all I would do here is I would think about 1 in terms of halves. There's 2 halves in 1, so that's like minus 2 over 2 minus 7 over 2 equals c. And if you're good with your fractions, you'll be able to work that one out. That'll be minus 9 over 2 is equal to c. So what we've got is c is equal to minus 9 over 2. Okay, so I'm just going to pull these together. So remember, what we're going to do is we're going to substitute the m is equal to, so it was minus a half, and the c value, which was down here at minus 9 over 2. I'm not simplifying that down to minus 4.5. I'm just going to leave it as a fraction, and we're going to put it into y equals mx plus c. And what we've got from there is y is equal to my gradient minus a half x, my c value, minus 9 over 2. And there's my answer there. Okay, a couple more to go. Okay, and again, you can freeze the video if you like and try these ones here. So I've not got a gradient, so I'll work out my gradient. So minus 5 take away minus 5, all over 4 take away 2. So minus 5, and that'll be a plus 5, gives me a 0 on the top there. That'll give me a 2 on the bottom. 0 divided by 2 is 0, so that'll be a horizontal line that's there. So what I'll do is I'm just going to go through the mechanics of this. So what we'll use is y equals mx plus c. What we'll do is we'll use that one for my x and that one for my y. So that'll be minus 5 at this side is equal to, my gradient worked out to be 0 times by x, which is 2, plus c. So remember, this will work out to be 0, so it'll be minus 5 is equal to c, or c is equal to minus 5. Okay, and then all I'll do is I'll substitute that back in. So I'll substitute the gradient 0 and my c value of minus 5 into y equals mx plus c. And when I do that, what I've got is y is equal to m, which is 0, x minus 5. But remember, that equals 0. That equals 0. So to finish that, I'll just say that y equals minus 5. And some of you will probably have got there before me anyway, when you see that, when you see the coordinates. So I've got a minus 5 there and a minus 5, 0 gradient. Well, that's a way that we could just work that one through straight from there. Right, let's do the last two that are here. So same thing, I don't have a gradient, so I'm going to have to work that out. Don't have a c value, got to work that out. So gradient is equal to minus 3 minus minus 12, and I've got 8 minus minus 4. Okay, so I just usually write it out like that rather than converting it to a plus. So that's minus 3 plus 12, that's going to give me 9 on the top. 8 plus 4, well, that's going to give me 12 on the bottom. I can divide top and bottom by 3 and get 3 over 4. Okay, so that's my gradient, 3/4. I'll substitute that into this equation that we're going to be using, and let's go for it. So I'll go for, this is my x value, this is my y. So minus 12 is equal to my gradient, which is 3/4. We're going to multiply that by the x, which was minus 4, and we've got a plus c, and remember, that's the one we're trying to work out. 3/4 of minus 4, so it's going to be a negative answer, isn't it? So that's going to be a negative something. 4 divided by 4 gives me 1. 1 times 3 gives me 3. So 3/4 of 4 is just 3. And because it's a negative, it's a negative 3. I'm going to add 3 to both sides. And what that will give me is minus 9 here. These get eliminated, and that's my c value that I've worked out now. Okay, so c equals minus 9. So got to be good with your fractions, starting to get good with your negative numbers as well. Right, so we're going to substitute my gradient of 3/4 that we got up at the top there. And we've got the c value, which is the minus 9. So we're going to substitute them into y equals mx plus c. And we'll just get a result from there. Y equals 3/4 x minus 9. And that's the equation of that straight line. Right then, so getting a wee bit more complicated when we move down and get the fractions into some of these equations that are here. So f, the last one of this type here. Right, you freeze the video, try it yourself. I'll be doing the answer now, okay? Don't have a gradient. I don't have a c value, so what I'm going to do is I'm going to find my gradient first of all. So gradient is equal to 4 minus minus 1, so that take away that take away that. Okay, so that's going to give me a 5 on the top, that'll be a 2 on the bottom. That's a top-heavy fraction, can't simplify that. I'm not going to change that to 2.5 or anything like that, I'm just going to leave that as 5 over 2. Okay, so I'll then use the equation of a straight line. I'm going to substitute the values in. I'm going to use that as my x and that as my y. I would sometimes choose the 5 and 4 because they're both positive numbers, make it a wee bit easier for myself, but I'm just going to go straight ahead and work this one out. Right, so for y is minus 1, m is 5 over 2, and the x value is 3, okay, plus c. Right, so from there, what we'll do is we'll just work this through. So that's minus 1, and that's going to be, if I work that out, so 5 over 2 times 3, remember 3 is 3 over 1, and when we're multiplying fractions, we just multiply them straight across the way, so 5 times 3 is 15, 2 times 1 is 2, plus c. So remember, 1 is going to be 2 halves, so that's going to be minus 2 halves. I'm going to then subtract from both sides the 15 over 2, if I can just cut that corner there a wee bit. Okay, so that's me just trying to solve this equation. So that will give me minus 17 halves for c. So c is equal to minus 17 over 2. I'm going to just substitute my values in now I'm going to substitute my m, which was 5 upon 2, that worked out up above, and that c value that's just sitting there, 17 upon 2, and what that's going to give me is, so y is equal to, and my gradient, 5 upon 2, x, and it's going to be negative 17 upon 2 for c. And that's my answer there. So, some reasonably complicated once we get down with some fractions, some negative numbers, got to be really kind of sharp on them, okay? Right, so just to finally kind of put this one away, what we'll do is we'll look at a couple of exam questions. And these should be reasonably quick to do for us. So what we've got here is we've got a straight line that's drawn, and what we've been asked to do is find the equation of the straight line shown in the diagram. Right, so what we could do is we could see a c value that's there of 5. So I could substitute a 5 in where the c value is, okay? And what I could also do is work out the gradient. So my gradient, it's not a 2 along and 1 up, so it's not a gradient of a half. You've got to be really careful and make sure that you look at the scale that's there. So every time I go along 2, I seem to go up 5, along 2 and up 5, okay? So that gradient there would be a 5 upon 2 gradient. So for that one there, if we did it just in the quick way that we could do it, we would say that our c value is equal to 5, because that's where it's cutting through this point right here. And we said that our gradient that we worked out just looking at it is 2 along. Okay, so that's 2 on the bottom. And we go up by 5, just making sure that we keep in touch with the scale that's there. So we're going to substitute them. And we're going to substitute them into y equals mx plus c. And if we substitute them in, straight away we get y is equal to 5 upon 2x plus 5. And that would be the equation of the straight line there. Okay. Sometimes it's not as easy as that, and we can't see where this point in here is, you know, so we wouldn't be able to use that one. But what we could do is pick 2 other points. We could pick that point there, which is 210. And what we could do is pick another point like 620 that's here. 620, so that would be that point that's there, and we could go ahead and work out the gradient based on that and work out our c value. So my gradient is equal to, so it's going to be y2 minus y1 all over x2 minus x1. That will be 20 take away 10, and it's going to be 6 take away 2. And if I work that out, I've got 10 on the top, I've got 4 on the bottom, and if I simplify it, that'll simplify down to 5 upon 2, same as the gradient we had up there. If I then use what I learned in the previous slide, y equals mx plus c, I'll pick one of the points, the 210, so I'm going to pick this one as my x and that my y, so that's going to be 10 is equal to my gradient, which is 5 upon 2, times the x value, which is 2, plus c, so 5 over 2 times 2, so that'll give me 10 over 2, which gives me 5. So that's 10 is equal to 5 plus c. Take 5 away from both sides, leaves me with 5 for the value of c. Okay, if I've got c is 5, so it's the same as that there. I've got the gradients 5 upon 2, same as that one there. So here we would just go for y equals mx plus c, and we're going to substitute my gradient equal to 5 upon 2 and the c value equal to 5. We'll just substitute them into that there. So y equals 5 upon 2x, and that's going to be plus 5. Same as up above, okay? Right, so that's one of the exam questions done. Last one, last thing that we're doing in this video. So I've got this question that's here. So good thing about this one as well, I can see that my c value is equal to 8. I've got an x value there and a y value there. Remember that point there is a 0, 8, okay? So that's the coordinates of that point that's there. So I can work out either a quick way of doing it or the way that we've been kind of doing on the last couple of slides. I'm going to do it that way. So I'm going to work out my gradient first of all. So I can say that my C value is equal to 8. I'll get a mark for that. Okay, so let's go and get our gradient. So our gradient is equal to y2 minus y1 all over x2 minus x1. Substitute 12 in, take away 8, and remember that was 0, 8 as the coordinates, so that's going to be 6 take away 0, and then what I'll have on the top is going to be 4 all over 6, and that will simplify down to 2 over 3. So there's my gradient. So y equals mx plus c, and if I substitute the gradient in, which is 2/3, y equals 2/3 x, and we've got a plus 8. Okay, and that's the way we can work that one through there. Okay, alternatively, we can substitute in, like we did in the last question, into y equals mx plus c, work out the c value, and go from there. But we've already been given it. Okay, and that's 2 exam questions to finish. Okay, so hopefully this has helped you through. I've gone through it reasonably quickly. I've done quite a lot of examples there. Please just go back and check them out as you go forward. Make sure you check out the negative numbers. Make sure you check out the fractions because they are key as well. And good luck with the rest of this work. Next time we do a video, I'll probably use a different equation, y equals mx, y minus b equals mx minus a, and we'll see how that one works out as well. Okay, so good luck.